Hi, this is Mrs. Sigala, and this is the homework for units 4.4 and 4.5, which are due tomorrow. Okay. In order to complete this homework, you need your periodic table of elements and your polyatomic ion charts. All right, so we're going to start off by naming polyatomic ion compounds, and here we have a combination of covalent, ionic, or polyatomic formulas. And so the very first thing to kind of keep your mind on track is stick to one rule at a time. You don't want to be skipping from covalent to ionic to polyatomic, otherwise we're going to forget. And so what poly, the prefix poly, to me, well, it means many. Okay, so in this case, we're looking for more than two elements in our formula, and some of those will have these polyatomic ions right here to the right. Okay, so I'm going to identify, and the easiest way to probably do that is to look for the amount of capitalized letters. And so I'm going to go through my list first, and I'm going to identify all of my polyatomic ions first. So I go to number 1, and I notice that number 1 has 3 elements, so right away I know that this is a polyatomic ion. Number 2, again, we have 1, 2, 3. Again, polyatomic ion. Okay, I'm going to erase this, we don't have this here. I keep going. Well, in this case, number 3 only has 2 elements, so that is not a polyatomic ion. I'm going to come back to that one. Number 4 only has 2 elements, not a polyatomic ion. Number 5, polyatomic ion because it has 3 elements, I'm sorry. Number 6 only has 2 elements, so it is not a polyatomic ion. Number 7, not a polyatomic ion. Number 8, wow, that is a huge one. So that one, in this case, there's 1, 2, 3, 4, 5 elements. That is definitely going to involve polyatomic ions. Number 9, no. Number 10, no, because there's only 2 elements. 11, in this case, let's count them. We have 1, 2, 3. Yes, we're going to have a polyatomic ion involved in there somewhere. Number 12, yes, we have 1, 2, 3 elements, so we have a polyatomic ion. 13, nope, we only have 2 elements, so not a polyatomic ion. Number 14, we have 1, 2, 3. Yep, we have a polyatomic ion. 15, definitely a polyatomic ion. 16, no. 17, we have 1, 2, 3. Yes, polyatomic ion. And 18, also a polyatomic ion because we have 3 elements involved. Okay, so I'm going to erase all these little dots. All right, so next I'm going to go and start naming my polyatomic ions first, and that way I kind of stay in that same reference of mind. Okay, I'm not going back and forth. So my next step with my polyatomic ionic compounds, I'm going to identify that polyatomic ion. And remember, it has to be on this list, okay, right here. And so when I go to Na2SO4, okay, I have to recognize, and this is only going to come with practice, that SO4 is going to be found right over here. So here's SO4, and remember the name of your polyatomic ion does not change. So the rule is if you start with the metal, and in this case we do, because my polyatomic ion comes first, my metal in this case is sodium. I'm going to write down the name of the metal. So in this case, the metal is sodium. And with polyatomic ions, these names never change. So I look over to see what the name is for this molecule, and it is sulfate. So my compound is called sodium sulfate. All right, number 2. I have Ca3PO4 and then 2. Usually or sometimes this polyatomic ion will be in parentheses, so I've identified it as PO4. I'm going to go to my list, look for PO4, and right away I've identified it. I'm going to put this in purple so you can see a little bit better. So here's PO4, and this is for phosphate, okay? And so again, my first rule is naming my metal. In this case, my metal is going to be calcium. So it is calcium. And my polyatomic ion's name is phosphate. Oops, space. All right, number 5, I want to identify my polyatomic ion. And usually the polyatomic ion will be towards the end or at the end. The only polyatomic ion that you can potentially find in the beginning is ammonium, and because that one acts as a cation. Other than that, if you don't see that listed first, your polyatomic ion will definitely be second. Okay, so I go to number 5, and because NH4 isn't first, I look for MnO4. MnO4 on my list is right over here. It is permanganate. Again, I list my metal first. My metal is potassium. Permanganate. It's a really long name. There we go. Okay. All right, number 8. Wow. Okay. Again, we have to identify our polyatomic ion. And I noticed that NH4 is listed first. So here's one polyatomic ion. But then I have to be careful because in this case, we have a combination of 2 polyatomic ions. And so again, the rule is you're going to name your polyatomic ion first or second. Okay, in this case, that's all we have. So I look for NH4. It's the first, one of the first ones on my list. It is ammonium, so I'm going to write down ammonium. And my second polyatomic ion is C2H3O2. C2H3O2, which is right over here, and that is acetate. So the name of my compound is ammonium acetate. All right, number 11, I have KCO3. Again, my polyatomic ion is listed second because it's not NH4. And so I look for CO3 on my list. And by the way, you'll be able to use this list during your tests, so don't worry about having to memorize them. And I notice that it is carbonate. So again, my metal is potassium. And it is carbonate. All right. Next one, sulfate. Okay, so and little by little you'll start memorizing some of these, whether you want to or not. So I see SO4 again. It's right here. And so I have my metal, which is cesium. So this would be cesium sulfate. Okay, number 14. Again, there's my polyatomic ion. It's NO3. I identify it. It's nitrate. Again, I'm going to list my metal first, which is barium and nitrate. Okay. Next, I have number 15. It's a longer polyatomic ion. Okay, right over here. And I look for C2H3O2 on my list. It's right over here again. I have acetate. So this one, again, list my metal first, which is lithium acetate. Number 17. Again, I notice that my polyatomic ion is CrO4. So on my list, CrO4 is right over here, and it is for chromate. And so I list my metal first, which is lithium, chromate. All right, and number 18, my polyatomic ion is listed second, and in this case it is called cyanide, which is very dangerous to us. Okay. And so the metal, again, is potassium cyanide. And those are my polyatomic ions. Okay, I'm going to go back, and I'm going to, next, so I've done all my polyatomic ions. Okay, so I got those out of the way. And now I'm going to identify my covalent. Okay, and again, covalent compounds must all be found to the right of the zigzag line. I'm going to darken this zigzag line up a bit. So here's my zigzag line. Okay, and this is a little easier because all my nonmetals are going to be to this side. Okay, And if we have a bond between two nonmetals, here we're dealing with a covalent compound. I'm going to abbreviate compound. All right, so that just means that both elements must be found to the right of the zigzag line. So I look for P and H. So I have phosphorus right over here. And the only nonmetal that's found to the left of the zigzag line is actually hydrogen. And so I did find it there. So again, this is a covalent compound. Oops. I don't know what I did here, but let me erase that. Okay. Then I have iodine and oxygen. So I'm going to look over here for my nonmetals. And again, I've spotted over here. Here's iodine. Here's oxygen. So again, I have another covalent compound. Potassium, nope, that's not to the right of the zigzag line, so automatically that makes it ionic. But I'm gonna come back to that one. So I'm looking. The next one that I find to the right of the zigzag line is silicone. So silicone, which is for number 13, right over here, this would also be considered covalent. Okay? All right, now the rule for covalent, this is the only time that we're going to be using prefixes, okay? And again, the rule for covalent, we use mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca, except for we never use mono for the first elements. So in this case, this would be phosphorus, tri, oops, I didn't leave myself enough space. Let me erase this real quick. Tri, because I have 3. And I'm going to use the root word hydride, and I'm going to end with IDE. Okay. All right, my second one would be, I have 2 iodines, so I do use a prefix here. Should be diiodine. And I have 5 oxygens, so it would be pentoxide. Okay. Again, my last covalent compound I have down at the bottom, and it would be silicone trioxide. Okay, and next I'm going to identify my ionic compounds. Cross out covalent. I'm going to use a different color so we can see them a little bit better. I'm going to use dark green. And I'm going to confirm that these are ionic. So what that means by ionic, it means that we're going to be dealing with a metal and a non-metal. Oops, let me erase this. Okay, so we have a metal and a non-metal. Again, your metal is going to be a regular metal. It's not going to be a transition metal. So the metals, the only metals that we're talking about in this case are going to be found in this area, because we know that these elements, these metals, have set oxidation numbers, okay? And we'll get to that in just a minute. So be careful not to waste time looking to the right of the zigzag line or looking to in this center area. We don't want to look there. Okay, we're only going to be looking in the areas I've circled. Okay. All right. So then we have potassium, a metal. Is it? Yes, it's right here. It is. Oops, right here. And the rule for ionic bonds, again, you just you name your metal first, and then you list your non-metal. In this case, it's sulfur. Okay, but you're going to change that ending to "ide." So in this case, again, ionic. So this would be potassium sulfide. All right, next we have I'm going to Ooh, I missed one. So next we have sodium. Okay. And I know that that's ionic because, again, sodium is right over here, number 11. And iodide. Okay. Next one, I have P. Oops, looks like I made a mistake. And this is what we have to go back to our periodic table of elements. Okay, I'm going to erase these over here. P is actually not a metal. P is a non-metal. Okay, so that's my mistake. And Br is also a non-metal. So this one, PBr, is actually a covalent compound. So that was my mistake. So in this case, it would be phosphorus, tribromide. I apologize for that. Okay, but that's just a good example of why we must always go back to our periodic table of elements. All right, I'm going to continue with my ionic compounds. Hopefully the rest are okay. And I'm going to look for Rb. Again, I'm only looking in these small areas that I've highlighted. Right away, I find Rb in group 1. So that is rubidium. I'm going to write down the name rubidium. So yes, it's definitely ionic. So that's my metal. And my non-metal in this case would be nitrogen, so I'm going to change that to nitride. Okay, next one we have CaP, so yes, calcium is a metal. Element number 20. P is phosphorus, so it's going to change to phosphide. And I believe that is it.